In this lesson, we'll be taking a look into the relationship between classes and scripts in order to look at how we can control our audio events from multiple sources. We'll introduce ourselves to static variables and talk about which variables we might want to make static, and we'll also be telling our music event we created back in the event instances lesson to stop when the player enters the portal from the teleporter script we created in our first parameters lesson. So in the last lesson, we learnt that by using our FMOD commands, we're actually calling upon pre-programmed functions and methods from scripts written by the FMOD developers. We were able to call these functions by referencing the script, or rather the main class that they were created in, as well as any namespaces the class was declared in as well. So you might think that by this logic, all we need to do to control an event instance variable from another class is to write the name of that class and its required namespaces, followed by a variable. Well, this unfortunately is not possible in our game because all of the variables we've created so far have been non-static members. So before we take a look at our scene, let's quickly understand what static members are and how to use them. So a static member is a member that is consistent across all instances of the class it was made in. What does this mean exactly? Well, let's break it down. The first term member simply refers to a method, function, or variable. Remember that a method is just another term for a function, and the reason why I'm clarifying this is because technically they do have a slight difference between them. However, for the purposes of implementing audio from FMOD, we don't need to know the difference and can treat them as the same thing to help us recognize them in our C# code. Okay, so now we know that either a function or a variable can be considered static. What does it mean to be consistent across all instances of itself? Well, let's say we created a script and we called it A. As we know, inside this script we have a class by the same name, which is also called A. Let's also say that within class A, we create an integer variable called number and set it to a value of 5. We then create two separate copies or instances of that class and script. Now in Unity, we can do this by attaching the script to a game object twice or attaching the script to two separate objects. So say, for example, one was attached to our player game object, Ellen, and another was just attached to an empty game object we created. Now let's say that we were able to control everything within these classes from an external source, like another script called B. Now if we use B to change the value of the number integer from within the first instance of class A from 5 to 10, the second instance would still remain the same. It'd still remain at 5. The reason why is because the number variable is non-static. It can have different values amongst the instances of class A. So in the first instance of A, it is 10, and in the second, it's still 5. Now, let's start again, but this time we'll make the number variable static by writing the keyword static before its data type. If we then use class B to change the value of the number variable from within either instance of class A to 10, the value of it from within the other instance of class A will also change to 10. So no matter what we do to the number variable in one instance of A, it will always remain the same across all other instances of it. The same general idea applies to static functions, and you can even have static classes too. But the reason why we need to know this for our audio is because a variable's static condition will dictate how we can interact with it from another script. Going back to our example, I mentioned that we were able to change the value of the number variable from class B. If that number was non-static, then we'd have to declare which instance of class A we wanted to change the number variable of, as number from the first instance can be different from number from the second. However, if number is static, then we don't need to declare an instance of class A, as every instance will be affected by the change. So with this in mind, let's look at one of our old event instance variables we created and see how we go about changing it both as a static and non-static variable. So to demonstrate how static and non-static members affect our variables, we'll be editing both the music script and the teleporter script so that when the player enters the teleporter, the music will fade out so that we don't have to wait for the level to completely end for it to stop. And the first thing we need to be aware of then is our event instance variable called musicInst. And we can see that this variable is non-static as the keyword static has not been used when declaring this variable. This means that we're going to need to reference the instance of the music script class to tell our code that it is this variable exactly that we want to influence. So to do this, let's go over to our teleporter script, which we called f_teleporter, so that the first thing we need to do in this script is to store a reference of the game object that has the music script instance attached to it in a variable. So at the top of our script, let us write private game object, call it music object, and end it with a semicolon. Now that we have our variable ready, there are two ways we can reference our game object. The first is by using Unity's find function, which will search for a game object based on the name that we give it. So inside our start function, we want to declare our music object variable, and we want to set it to reference a game object that we are going to find using the find function. Now inside these parameter brackets, we want to give the function a name in the form of string data. So since we know that in Unity, we called the object that has our music script attached to it music object, as seen here in the inspector tab, we want to write in the brackets music space object. Now this method works quite well, however you should be wary if there are more than one objects in your scene that shares the same name as the one you're referring to. So our other option in that case would be to make a variable public and select the specific object we're after in Unity. So let's then first edit our variable up here, change it from private to public, and then once we've done that, save our script. Then once we're back in Unity and our script has compiled, we can select the transform start object in the hierarchy tab, which is the object our teleporter script is attached to, and we'll see our variable music object has now been serialized. It's currently telling us that there is no reference of the game object type stored inside of this variable. So to fix that, we simply click, hold and drag the object we'd like to reference into this space from the hierarchy tab. So let's click and hold on our music object, drag it over to the inspector tab and into the music object space, just like that. Now that we've got our object reference, we need to reference the script and class attached to it. So to do that, we need to create another reference variable. This time, its type will be the same as our class name, which is music player. So we're going to write private music player and call it MP for short. Now, just like we did in the 3D positioning lesson with the transform component, we want to get the music player component and store it inside this variable. The difference this time is that it is on a different object to the script we're currently writing in. But thanks to our music object variable referencing the object in question, we can write in the start function MP equals music object dot get component music player. Now remember that by using the dot operator, we're accessing the music player component from our variable that is referencing the music object. And now we're able to access non-static functions and variables from our music player script. Now remember, we're trying to tell our event to stop when the player enters the portal. So going back to our music script, we'll remember that our event is a variable called music instance. So to tell this event to stop within our other script, we need to give our other script the class or instance of that class that contains the event followed by the name of the variable within it. Before we do that, however, we need to make sure that this variable is accessible by other classes. So to do that, we simply write public in front of it. Then let's go back to our teleporter script, where we'll be telling our event to stop inside our onTriggerEnter function, specifically inside the if statement we created that checks for the Ellen game object. So we're now going to need to give our statement a body and quickly take our set parameter by name command, cut it and paste it in here. So let's start with the reference to the script and the class inside of it, which is MP. Then let's state which variable contains our event, which we know is the music instance variable. Finally, let's tell it to stop, and inside the parameter brackets, write fmod.studio.stop_mode and tell it to fade out when stopped. And there you have it. We've just told our event from one script to stop according to another. Let's quickly make sure we save both the teleporter script and the music player script so that they both work, and jump into our game to see what happens. So now when we walk into the teleporter, we can hear that at the same time our teleporter event was told to end, our music has as well. Finally, let's look at the differences we'd have to make if our event instance variable was actually static. First, let's actually change the variable to static by writing the keyword static in front of it, just like that. Now remember, now that our variable is static, whatever is stored inside of it will remain consistent amongst all other instances of this script and class. In the case of our event instance variable, if we added this script to another game object and tried to change the event path assigned to this variable, the path assigned to this variable attached to the music game object would also be changed. We know that because this event is playing music for our scene, we'll only be making one instance of this script, so we can freely keep it static and not need to worry about changing the event path. So now that our variable is static, we can make some changes to the teleporter script. So let's go back over there. Now remember back to the beginning of the lesson, we learned that when referencing a static variable, you don't need to reference a particular instance of the class it was created in, as it will remain consistent amongst all other instances anyway. So because of this, we no longer need to reference our music object inside a variable, nor do we need to reference the instance of the music script we're using as well. Therefore, we can remove both of those variables that we declared, as well as the extra line we wrote in our start function, getting the music player component. Now that we've done that, we need to change our onTriggerEnter function. So let's replace the MP variable with the name of the class that we're changing the variable from, which is in the music player class. We can see now by the green color of music player that we're now referencing the class directly to tell the variable inside it to change. Let's then save our teleporter script, save our music player script, and then jump back into Unity to test it in our game. So let's once again walk through the teleporter. To hear the music stop. And that's it. We've now learned the difference between a static and a non-static variable. Thanks to this understanding, we can change and affect an event instance variable we create from different scripts by referring to the instance of the class we created it in. This is really helpful to know when trying to make your own audio more interactive and adaptive to other aspects of a game, as we're now able to start, stop, release, change parameters, call 3D attributes, and more by using this tool. So with that, you've just finished Module 3, and you're on your way to finishing this course. There's just one module left that focuses more on controlling our audio as a whole, rather than individual events and sounds that make up our soundscape. But before you dive into that, feel free to experiment with your newfound knowledge of static variables and how you can control your audio through multiple scripts. Like I said, it's a very handy tool to have, so make sure to make the most of it. Once you've done that, I'd say you've earned yourself a well-deserved mid-module break. Thanks as always for watching, and once you feel ready to jump back into it, head on over to Module 4 and I will meet you there.